So in this video we're going to look at solving simultaneous equations. This time we're going to use a method known as Cramers Rule, which is used in matrices. So Cramers Rule essentially uses determinants to help us to solve these kind of systems where we have to find x and y. So solve the following system of equations using Cramers Rule. So if we have a system of this form, x plus y equals 7, 2x minus y equals 2, so that's a 2 by 2 system. It's two equations and two unknowns. So what we need to do, we need to split it up into three matrices. We need to construct three matrices from this. The first matrix will contain the coefficients of x and y. That will be a square matrix. So we'll call that capital A. So that will be 1, 1, 2 minus 1, because that's the coefficients of x and y in the system. We will need a second matrix. I'm going to call it capital X. That's a column matrix. That's for our variables, little x and little y, which we need to find. And a final matrix, third matrix, called capital B. That's a column matrix as well, and that's a constants matrix. So that's the values of the equations, 7 and 2. Now we need to move on to the determinants. First of all, we need to find capital D, which is the determinant of A, which is this matrix here. So to find the determinant, we calculate AD minus BC, where A is the top left entry, B is the top right entry, C is the bottom left entry, D is the bottom right entry. So AD minus BC is 1 times minus 1 minus 1 times 2. So that will be minus 3. So we can always quickly calculate that. However, we need two more determinants. So there's a little bit of work involved in this. So we need, for each I, we need to find dxi, which equals the determinant of A with the ith column replaced with capital B. So we replace the ith column with the column matrix 7, 2. So if we were to replace the first column, if I was 1, we would replace the first column, 1, 2, with 7, 2. If I is 2, we would replace the second column, 1 minus 1, with 7, 2. In a 2 by 2 system, I equals 2. So we need dx1 and dx2, or dx and dy. So the solutions for xy will be x equals dx1 over d. So that's the determinant of x1 divided by the determinant of a. Y is equal to dx2 over d. That's the determinant of x2, or determinant of y, over the determinant of a. Now to get capital D, that's equal to the determinant of A. We've already done that. 1 times minus 1 minus 1 times 2, which is minus 3. I've put a little pink box around it. So that's one of our determinants we've found. We just need to find two more and we're done. So we need to find dx1 or dx. So that's the determinant of 7, 2, 1 minus 1. So we've just replaced the first column with 7, 2. So that's 7 times minus 1 minus 1 times 2. And that's equal to minus 9. I've put a little pink box around that as well. So the ones with the pink boxes around them are the determinants. This is all we need to solve the problem. And finally, dx2 or dy, that's the determinant of 1, 2, 7, 2, where we just replaced the second column with 7, 2, the constant matrix. So that's equal to 1 times 2 minus 7 times 2, and that's minus 12. So therefore, x equals dx over d, which is minus 9 over minus 3, which is 3. And y is equal to dy over d, which is equal to minus 12 over minus 3, which equals 4. So that's the answer to our original system. X equals 3 and y equals 4. you can quickly go back and verify that. 3 plus 4 is 7. 6 minus 4 is 2. Now, one little thing before we go that we need to point out, when you're using Cramers Rule, it only works if the determinant of A, the capital A, the matrix capital A, is non-zero. So if that determinant was 0, right, then this won't work, because we will have x equal to dx over d, where d is the determinant of A, and that would be 0. So we would be dividing by 0. And the same for y, we'd be dividing by 0. Now, we're not going to cover that case in this video, but what that would mean basically is you're either going to have infinitely many solutions or you're going to have no solutions. So when the determinant of A is non-zero, we can apply Cramers Rule and we will always find unique solution. So I hope this video helped, guys. Thanks for watching. Please like, share and subscribe, and I will see you on the next video.